Okay, here's where it's going to get a little touchy here. We want 2 inches of cut here at 5/16 of an inch diameter. So I'm not quite sure how this is going to go. I'm going to speed this up because we need a little bit more speed, and I think the feed, everything else is good on our combination here. Okay, that took it down to almost 7/16. I'm going to get my micrometer. It's actually the size here, it's a little bit big here, but that's because of that spring cut right there. We're going to leave it right there and we're going to take another cut. Just right out there at the end. I'm going to take a little paper, polish it. Another 1,000. Close, real close. Okay, that should fit. Alright, I'm going to pull it out, I'm going to part it off, leave a little knob on the end here. Alright, let's check the fit. Alright, we went and got our DeWalt pistol drill here, and we're going to get this plugged in. Alright, now this is a 5/16 drill bit, and that's the size we got in here, and we'll be able to see our drilling going in right here. And go ahead and get this set up here, and all we need to do is go in, I don't know, about 3/8 of an inch or something like that, fully get our drill bit all the way in here, so now it's being guided by the cast itself, and we're not going to be harming those threads out here, which is the 3/8 thread. So it has a 3/8 set screw and then a 5/16 pin with a wedge shape on it, and that's how this actually works. Okay, that carpet's drilling really easy, and I look in, it's not chipping at the edge. I'm just at the outside surface right now. Okay, I'm in there about 1/4 of an inch. If I was to hold this right here, about 1/4 of an inch. Alright, I'm going to set this down, and we're going to grab the shop back here. And our piece goes all the way in, and it's actually pretty firm. That's a nice tight fit in there. Alright, so our drill is drilling real close. Now we're going to go ahead and I'm going to rotate it over here so we can come in and get this one. Here again, all the way in, so that we're using the bore to guide our drill. Okay, right there is flush. That's approximately 1/4 of an inch in. Maybe a little bit more. Here again, vacuum. Insert our other 5/16 pin, and it's pretty. That's pretty. I mean, they're in there. That's pretty snug fit. Excellent. I'm going to get a couple shots there. I can see one little burr. When we push this through, it raised the rollover burr, that the rotary burr itself. There, I just chipped it off. It's right there. All right. I think a couple good photos of our dam here before we get started. We're going to go in and start prepping it and braze it up. Okay, we're starting to get some of our stuff over here. We've got a couple lengths of brazing rod, and that's just bronze alloy brazing rod, general purpose. Most of the time it's just marked low fuming, LF, BB, brazing, bronze, and I'm using a number 2 flux. It's a high heat flux. I normally use Peterson. I have some in there, but I've been finding that this borax actually does a pretty good job as well. The main thing is don't rush your job. You got to get it hot enough. If you get it hot enough, then temperatures are right, your flux will work right. So I'm forcing myself to use this because I'm training myself to be patient. And this, more so than the Peterson, you've got to be more patient. It seems like it's a little slower acting, but I've been real happy with its joining properties in the name brand. So I'm not knocking the product. I'm actually finding no fault with it, except for I might be pushing my brazing, the initial starting of brazing, and that's one of the main mistakes that I know a lot of people try to force this rod into your part, and brazing's all about gently flowing it where you want it, and then forming it, and it almost like drip castles on the beach. All right, you go too much and then you're going to have a collapse and a washout and all kinds of other things. All right, what I did is I've got this set up and my plugs are in here and everything's fitting up nice. I was thinking about doing it in the well position, being able to change angles and all that. That would be nice, except for my main concern is trying to create a repair on this piece without or minimizing the distortion, the movement, and the possibility of not needing any machine work. And that would be the ultimate goal, right? If I can braze this up, pull these plugs out of here, maybe do a little bit of ginger grinding or sanding on the top of the braze, and then maybe just lapping the surface smooth again on the top with no machine work needed for the bore or the spindle, that would be tits, you know. But we'll see what we got going on here. I got a blanket, and I've already pre-folded this blanket here, I think, to be able to go all the way around this. And this is so I can create heat without losing heat. All right, because heat rises, cool air rushes underneath. So if you block out the air travel from underneath, then you're not getting the cooling effect from underneath the part. And we know that we're going to be heating this, and we also have to heat our parallels and create a uniform temperature in there, so that when we get ready to go for the local area, it will heat up with no problem. And this is kind of through experience of getting the best bondage possible on your material that you're adding to the cast material itself. And here again, I get asked all the time, hey, how come you don't TIG or you don't stick? Or I don't like to turn ductile iron or cast iron, however you want to phrase it, into a molten. As soon as you change it into a molten material, it changes its structure as it cools. And you get brittle areas, and it becomes very unstable for stress and pressures and all of that. So by brazing it, I'm joining a material that acts very much like the cast iron, very, very much a secure grab of the cast iron, and easy to machine without that much difference between the bronze surface and the cast iron surface. So if you're going into resurfacing a mill table or a cast part, because over the years I've just repaired an enormous amount of machinery, and I learned from the old timers to do your repairs with brazing method. Now, I have gone into, I go, you know, I'm the first one. I learned to do something one way, and then I go, okay, what's the easiest way? So, I mean, you're always searching the easiest way, or the shortcut, or, you know, it's, all of us have done it. All right? I don't like that 50-50 chance. All right? I like a sure thing. And I've had more success with brazing, and I've had more sure things than that 50-50. That's why I braze. All right, so I'm going to go ahead and get this blanketed up. All right, afterwards we'll go ahead and we'll throw another blanket on, and I think I can just easily do that. Okay, so we're good to go there. I'm going to get my torch, get over here, and then we're going to get started on this. Okay, I think I'm pretty well set to go. I went ahead and put a block behind this so that it give it tilt, because when I'm brazing, the going uphill or doing a gradual incline, is much easier to get the braze to flow in and grab where I want. You don't want to roll ahead of your braze and ahead of your joining puddle and fall into a hole and create a lap. A lap means to me the molten surface rolling over in front of itself and then cooling without joining, and that becomes a lap. It's not, it's there, it's filling the void, but it's not actually bonded to it. So when you're brazing, your very first pass that goes in there has got to bond. It's easy to mix the, or it's easy to join braze to braze, but your first initial pass is the most important thing when it comes to brazing. All right, we'll go ahead and set the flux over here out of the way for a little bit, and we're going to go ahead and preheat. No, we haven't used this torch in a while, so I'm going to let some gas. It'll probably blow out on the oxygen as well. We got some temp sticks to go ahead and check our progression of temperature. The first one is 500. You want the whole thing to heat up evenly. Once you get above 500, between 500 and 1,000 on the overall whole part, then you can start locating more heat into the center area, and then you want to bring that up to a certain temperature. Then you can start really focusing where you want to put the braze, and your heat's not too different from any one part of the whole part as a whole. Okay, we're starting to milk the 500 pin. I'm going to take it on up a little bit more. I'm starting to get my gloves on here. It's repositioned here. Real close here. I'm about 1100. And then I've got 550 outside there, so this is a pretty good combination here. So I'm getting ready for action here, keeping the heat on it. I'm not trying to work around the cameras here, so I get to the best shot. First thing I'm doing is I'm flushing my rod. I really want to get that root right down around the bottom, really up to temperature. I want to see some of that glowing red in there. This deposits the flux down in there. So you gotta have that really nice and red down in there, otherwise you're not going to get it all the way to the root. Alright, now I like to start up here. See how it just flows right in there. That held in there pretty tight for the first pass. I like that. Now I'm going to go up to the other side here. I'm going to switch ends. Make sure I don't switch the ends of the water. Same thing here. Better right-handed with my fork, so. Okay, now that I'm down there, I'm going to take out the block. Let it lay flat. Woo. Alright, I'm gonna be happy with that. I know I got a good bond in there. It looks pretty close. It's up to the part there. As long as we have that lifting pressure on those little fingers in there, we're gonna be okay. Alright, now we're gonna blanket it. I'm just gonna let it sit. It will cool down, I don't know, probably till tomorrow. And we'll take a look at it. That's about 9:15 or so the following morning here, and we're getting ready to pull off our cover here and check out our work. I'm going to go ahead and fold up my tarp here and get it back on top of the storage area here. Alright, this is looking pretty good right here. Now, one thing that I wanted to see is, can I actually pull these carbons out? And they're in there pretty tight. Let's go ahead and I'm going to finish unwrapping this thing, and we're going to get this all the way off of the clamps and everything else. And we're going to try to get, I don't know if we're going to have to press those out with the arbor press or what. I'm going to turn this upside down. This is an old set of jaws. I use them for things like that. See, somebody actually came in and caught that with a cutter. Anyway. Still pretty tight. Alright, let's just see if I'm going to have to go get another pair of pliers. Alright, so I'm going to pick up a couple things and we're going to go ahead and put away our clamps and stuff and right on back. Alright, I went ahead and grabbed a pair of pliers here. You know, let's see if I can just work this. If it breaks off, I'm not going to be